Welcome to qnawire.
So in this problem, we have two blocks that are starting at rest, and we want to neglect the masses of the pulleys and the effective friction in the pulleys, just assuming that the coefficients of friction between block A and the horizontal surface is a given value for static friction and a given value for kinetic friction. So we want to determine A, the acceleration of each block, and B, the tension in the cable. So the first thing to do with these types of problems is to draw free body diagrams. So for A, our free body diagram, we'll have the weight, mg down, normal force up, the tension in the cable, and the force of friction in this direction. And we'll go ahead and define our coordinate system as well. And then for block B, we'll have two wires pulling up. So we have one with a value of t and one straight up with a value of 2t, and that's straight up along the axis. It's just a little hard to draw. And we have the weight, or mg, down. So from the diagram, we can see that xa plus 3yb must be constant. Because they're at rest and in equilibrium. So we have the velocity of A plus 3bb equal to 0, and the acceleration of A plus 3ab also equal to 0, or acceleration in A is equal to negative 3, the acceleration in B. So the first thing to do is to determine if the blocks will move if the acceleration in A and the acceleration in B are 0. So from this, we have for block A, the sum of the forces in the y direction is 0, and this will mean that we have the weight of B minus 3t down equal to 0, or that tension is equal to 1/3 mass of B times G. And then for B, we have the sum of the forces in the x set equal to 0, which will mean that we have the force of friction minus T set equal to 0. And we know that this force of friction is equal to 1/3 times the mass times G, which is equal to 81.75 newtons. So this will leave us with this. And then we know that the sum of the forces in the y equal to B, or 0. So the weight of A minus the normal force of A is equal to 0. So we get that the normal force is equal to mg. We also know that the force of friction max is the coefficient of friction, and in this case it's static for A, is equal to the normal force in A. So plugging in what we just found for the normal force, that will give us the static coefficient of friction for A times the mass of A times G, which will give us a value of 73.575 newtons. So we can see that the force of friction will exceed the force of friction max, which implies that they will move. So now we want to know the acceleration. So now this is part A. So we can see that the sum of the forces in y for block A is equal to 0. So we have the weight of A minus the normal force of A is equal to 0, or the normal force in A is equal to mg. And we have the friction force of A is equal to the kinetic coefficient. This is equal to just plugging in what we're given in the problem. And we know that the sum of the forces in the X will be equal to ma. That's just Newton's second law. So we have our friction minus tension is equal to ma. And we know that tension is equal to this for block A. And we also know for the y direction in block B. So now we're working on block B. This will give us that the weight of B minus 3t is equal to ma. Or this, now we're just plugging in values. Okay. And that just came from this equation up here. So now we can go ahead and solve for the acceleration in B. So rearranging and plugging in values. This will give us a value for the acceleration in B of 0.233 meters per second squared. And now that we have that, we can go ahead and solve for the acceleration in A using that equation, which gives us a value of 0.698 meters per second squared. Okay, and then for part B, we already have our equation where we can solve for tension force, so just plugging in our values. This gives us a tension of 79.8 newtons.